Yeah, sure, Dan. So I'm Daniel. I'm a software engineer at Google. And today I'm going to be talking about how to make your machine learning production ready using TFX. So first I'm going to talk about what is TFX, and then I'll go into why we should use TFX. And finally, I'll walk through an example pipeline. TensorFlow Extended, or TFX, is a platform for managing production ML pipelines. When you use machine learning in a production setting, there are a lot of things that you need to do beyond just training your model. For example, data preparation, feature engineering, and so on. TFX allows you to take all of these things and then put them into a pipeline so that you can run them in an automated way. Why should we use TFX? Well, in a production system, everything is always changing. You have new data being collected all the time, and then every time you get new data, you probably want to retrain your model. Maybe there are new constraints in the real world. For example, you can't use a feature anymore because there's some new regulation in place. Or maybe you're updating your model, you're doing some hyperparameter tuning, or updating your model architecture. So in this rapidly changing world, TFX allows you to automate the repetitive process of retraining your model and deploying it to production. So not only does this save work, but also reduces the possibility of human error. It does this by consistently doing all the checks that you should be doing every single time. Another thing is it can help mitigate some forms of technical debt. So for example, your data might come from different sources, and then it can get messy as you accumulate more and more code just to get all the different pieces of data. So TFX lets you organize that so that it helps with the technical debt. All right, so let's walk through an example pipeline. Let's start with just a basic pipeline. First, we have Example Gen, which is a component that generates your training and evaluation examples from your data. Next, the trainer trains your model using the data. And then finally, the pusher pushes your model to production, to some server or anywhere else you might want to deploy your model. So these are all built-in components: Example Gen, trainer, pusher, but you can also write your own custom components. When we do machine learning, probably the first thing we want to do is look at our data. So we can do that using Statistics Gen. Here's what it looks like. Basically, it generates a bunch of statistics for all of your features. And then it will also look at any missing data or zeros that might indicate something's not right with your data. If you want to see the code for how this is generated, this is from the TFX Colab, which you can search up. It's just on the TFX website. Another way we can validate our data is using Schema Gen. This is basically like a type checker for your data. It looks like this. Now, if we want to automate the verification of our data, we can add an example validator. This just alerts you of any anomalies that it finds within the statistics or the schema, and you will know if you have something wrong in your data without necessarily having to look at it. Now we validated our data. Probably the next thing we want to do is some feature engineering. We can do that using the transform component. What's cool about this is it actually prepends all of your transform operations to your exported model. That way, when it comes to doing inference, you don't have to worry about whether the transformations you applied to your inputs were the same as when you trained your model. All right, so now we've trained our model, and then we want to see how it performs. So we can do that using the Evaluator. The Evaluator doesn't just compute a metric over your entire data set. it actually computes the metric for all of the slices within your validation set. For example, here's what it would look like when you visualize it. This is, again, from the Colab. It's using a taxi data set. It's trying to predict whether passengers tipped more than 20% given some features. And you can't see the labels here, but these are sliced by the trip, when the trip started, like the time of day that the trip started. And so you can see how your model performs depending on the various slices in your data. This is pretty important and powerful because in machine learning, inputs are not really independent. When you change one thing, that changes everything. So using this kind of multidimensional analysis helps you really understand what's going on with your model. If we want to automate the validation of our model, we can use a model validator. What this will do is it will check if the model meets your quality requirements and then only push if it satisfies those requirements. And that's it. Now we have a pretty fleshed out TFX pipeline. So that's a really fast, high-level overview of TFX. And if you want to learn more, I recommend you look at the TFX Colab. And that's it.
Beautiful. Thank you so much. I would like to take advantage, since I'm helping to host this event, and I will ask question first. I hope it's okay with everybody else. So this pipeline, it looks beautiful, and my question is, can I insert data collection components in this pipeline? For example, grab the command crawl and go and download all the 5 icons from these URLs. Is it possible in TFX?
Yeah, certainly. So you can probably have some scraping logic here, and then have them as a custom component.
Thank you.
One note: the model validator actually has been deprecated, so that functionality was folded into Evaluator.
Thank you, Robert.
Yeah, thanks. Good point.
Yeah.
Anybody else has questions, remarks?
So within TFX itself, is there something that, this is a nice pipeline and everything, is there a monitoring tool that would monitor this? So, something goes out of bounds, or, because this may take, hours to run, right, I assume. That goes out of bounds, that it will notify me to go deal with it, or, other sort of things?
Yeah, I'm not sure if there's any built-in functionality like that, but it would probably be pretty straightforward to make something like that. For example, the evaluator will output some metrics, and then you can feed that into some other piece of code that will send you an email, for example, if the metrics are outside of a certain range.
Is there a way to build? Oh, go ahead, Robert.
So there's also just the idea of, like, you're running a task and, did it crash or something like that? And so that kind of monitoring and alerting, that's really a function of the platform that you're running on. TFX runs in a number of different environments. So Apache Airflow and Kubeflow on Kubernetes, and you can run it on your laptop or whatever. So those kind of things really are more of a function of the environment that you're running in.
I was more referring to, let's say this thing takes, I don't know, a day, several hours to run. And if we fed it bad data, or for whatever reason, the numbers just are looking wonky, for lack of a technical term, is there some monitoring that can say, hey, something doesn't, this is just weird. Go take a look at this before you, charge up, I don't know how many dollars worth of time on the, GCS, in your GCS account or something like that.
Can you think of like a more concrete example?
You know, we're feeding in data from multiple sources, right, to train our models. And perhaps we got bad data or something like that from one of our, let's say we have 3 sources, maybe 2 of them are good and 1 of them is bad. And now the model is just, you know, just garbage, right? We really, really can't continue. We shouldn't move to these other stages beyond just, you know, some sort of initial test or something like that to see, you know, the model performance instead of being, you know, AOC is, you know, is just gone to hell. You know, it's got to be down there, and we'd like to stop and say, "Whoa, you know, this is not good. Let's go back to and figure out what's going bad before we waste the cycles, waste the time, and you know, just because somebody feeding it made an error or something like that."
So, so it sounds like you may be thinking of more of a real-time training situation where you're taking in data in real time and training your model in you know, in parallel with that.
Well,
if you're in more
over time, the model will drift, right? So you're going to be training, you know, the next version or something like that, if that's what you mean.
Right. So then if you're training in batches, you know, that's kind of what Statistics Gen and Example Validator are for, is to look at your data and look for issues.
Okay.
So, and you could write custom components too. If they don't give you enough of what you want to check, you can use either TFDV or any of the, you know, other tools you have available to you know, do that kind of checking against your data set before you you know, before you spend a lot of money on training it.
Okay.
So yeah, it's kind of a general problem. You know, there's different ways to approach that. You can look at statistics for your data. You can look for things like missing values and things that are the wrong types and that kind of thing. Or another,
Right.
you know, thing is just to train a very simple model or train a model for, you know, just maybe a couple of epochs just to make sure that, you know, everything is working right.
Mm-hmm. Yeah, I'm just thinking, you know, I've done systems, not necessarily machine learning systems, but, you know, but other systems where you had a lot of inputs from a lot of providers, if you will, providing you stuff. And sometimes the providers get it wrong, shall we say.
Sure.
And so, you know, I'm just trying to wonder how we wire it. It sounds like from what you said, the statistics gen should give me, you know, like I've done, you know, medical systems and things like that. And we've had people, you know, put things several orders of magnitude off or something, feed in data. They forgot to do some pre-processing on their end before they shipped it to us.
Right.
And, you know, their data is wrong, or, you know, step 1 of 5 that they should have done, or step 2 of 5 or something like that.
Right. So one of the things you get from the schema is the range of expected values.
Okay.
And another part of this is that you should really curate your schema. You should look at it once Schema Gen will make a best effort, but you know, you may know a lot more than it does. So you want to curate things like, you know, what are the expected ranges of these values? Are there categories here that I know I'm going to get for a categorical value that, you know, weren't included in the schema? Things like that help you add domain knowledge to it. But then that becomes, you know, really how you check to make sure that, you know, basic things like, you know, did a sensor go offline and now I have, you know, no data for, you know, 500,000 examples or something like that.
Exactly. You know, I've had systems that, not sensors, but, you know, similar type problems.
Yeah.
Where would that get wired in then? That would be in the Schema Gen, or?
Well,
Where would you? Yeah.
where would it get which part of that? So it's going to run through Statistics Gen. That's going to generate statistics, and you can do some customization around what statistics it generates. Then that's used by Schema Gen, and then you can curate the schema as well. And then both of those are used by Example Validator.
And then what's the mechanism then, I guess, to raise the flag that, we should just stop and continue on? Any one of these steps can do that? Or?
So there's no built-in alerting currently in TFX.
Okay.
So you can't say configure this component and, if it goes south, send me an email at this address or things like that.
Oh, okay.
It's something that we're looking at along with a long list of other stuff.
Yeah. I just think
I didn't mean to. This is your presentation, so I should really let you to.
No, you definitely know more than I do on this. I actually based a lot of my presentation on your video in the TF World conference. So this might bear a lot of resemblance to that. Just giving credit where it's due.
Yeah, I'm just trying to think of, I don't know, I'm sure others have built systems that have these pipelines, and typically they've been hand built and things like that. So you have a lot of these things, that you had to write by code. And I'm trying to figure out, if I were to build one today using TFX, I mean, what can I get for free and I don't have to maintain, I don't have to write, I don't have to, I can just buy it rather than build it. Yeah.
This is something we've had to build in-house in one of our prototypes. If I can provide a really concrete example of like where this need is missing for us and then what we had to fund ourselves. So for us, Jerry, we're running this in Airflow. So we have some hooks and mechanisms that we can use to halt a pipeline or otherwise send retry behavior. But we had to rig up that API ourselves and then kind of pass around the correct credentials inside of the TFX runtime and make that available. So the permissioning structure there is a little bit more elevated than I would like for a TFX pipeline. It's kind of like this pipeline that's running suddenly now has almost root or administrator permissions on all of Slack customer data. And that is a very scary prospect. It's hard to get that through approval systems. There's, like, that's a hard sell, I'm not gonna lie. So having the ability to lock that down a little bit more would be useful. We made a rules-based engine for ourselves. So just like really simple, trying to keep it as easy as possible, where we generate basically the output of Statistics Gen feeds into a rules-based engine, and then based on a number of rules, depending on the type, it's either a pass or fail, pass or hard fail, and then the hard fail will just halt the pipeline altogether. Some areas where we've struggled with this, though, is Statistics Gen doesn't necessarily express all of the types that we're interested in validating. In particular, locality-sensitive hashing is a strategy that we use where things can absolutely go awry. So what we do is we store high cardinality data as like 8 bits or 4 bits, and then use a strategy called locality sensitive hashing to try to approximate neighbor searches. A lot of our approaches are basically trying to figure out how to do approximate nearest neighbor with as little data as possible, as fast as possible.
Right.
And so that the hash space is something that we want to validate for any given either input and then occasionally the output of a model as well, just to see the distribution of the space. But there's not really a way to do this in TFX. We've had to build this custom behavior on top as well. I don't know if those kind of describe like solutions. Oh, sorry.
But you would want to do that anyway, right? Because that's very much tied to your hashing algorithm or whatever, structure you're using to give you that data distribution, right?
Yeah, but it'd be cool to have a bit of a pluggable system to interact with TFX. You know what I mean?
Yeah, I completely understand what you mean, but I mean, you guys are still going to have to do the major engineering effort, So, yeah.
Totally.
Anyway, yeah, I get that. My experience has been more with And drug discovery systems or drug performance systems with FDA approved data, if you have all these hospitals or, well, let's take COVID as an example, right? If you have all of these states reporting up and like 2 states don't report, you don't want to roll the stats. You want to call them up and go, hey, dude, what happened here? Why don't I have numbers from you and things like that for last week, and then roll them into your prediction model or something like that. And just sort of things like that. Most of mine has been like in drug production, drug discovery type work, so not quite that bad, but it's very similar data, same issues. We would get stuff from hospitals on drug production or drug testing, and sometimes their stats would be just garbage, literally. And we would spend 2 days crunching the numbers, and then somebody at the end, one of the data analysts would come back to us saying, oh, this is junk. I mean, didn't you guys catch this? So, yeah. But anyway, that's my rant. I'll turn it over to the next person who wants to ask a question.
I wondered, asking the audience this one, how are y'all adapting different data serialization strategies? To example, Jen, we're in a situation where we have to figure out thrift, Avro, some mixed proto, JSON, binary JSON, there's Apache Arrow input in there. So this adapter layer is on us to build right now. How are other folks approaching this, where they've just got a myriad of data types?
Lee, we should talk offline because there's some new stuff on that.
Ooh.
There's I don't know if you're familiar with TFX.io.
Don't think so. I don't think we're using it. I'll do some searching though. Thank you.
It's not well documented. Yeah, we're making big improvements to being able to pull in other data formats like that.
Oh, that's awesome. Thank you.
Yeah, if you want to drop me a line offline and we can get you hooked up.
Will do. Thank you.
Okay, guys, so we're getting close to the 30 minutes mark. And if we don't have more questions, I would stop recording. Sounds good?
Cool.
Yeah, thanks a lot for the questions.